States of matter, Unit 1.1 Solids, Liquids, and Gases. The core topics in this chapter have been listed over here. The first topic we'll be learning is differentiating the properties of solids, liquids, and gases. Then describe the structures of solids, liquids, and gases in terms of particle separation, arrangement, and motion. Describe the changes of state in terms of melting, boiling, evaporating, freezing, and condensing. Describe the effects of temperature and pressure on the volume of a gas. The supplement topics are explain the changes of state in terms of kinetic particle theory, including the interpretation of heating and cooling curves. Then explain in terms of kinetic particle theory the effects of temperature and pressure on the volume of a gas. The first topic here is state the distinguishing properties of solids, liquids, and gases. States of matter exist in different forms. The three different states of matter are solids, liquids, and gases. Properties of solids, liquids, and gases. Solids have a definite shape. Think about a wooden table. Liquids, they do not have a shape. It takes up the shape of the container they are poured in. For example, you're pouring water from a jug into a glass. Gases. They also take up the shape of the container. For example, the air around us is packed in a room, so it takes up the shape of the room. Density. Density is nothing but the relationship between the mass of a substance per unit volume. Volume means the space taken up by any object. Solids have a high density, liquids have a medium density, and gases a very low density. Volume. Solids have a fixed volume. Liquids, they also have a fixed volume, but gases do not have a fixed volume. Solids have particles that can vibrate about their fixed position. It means it does not move anywhere. In liquids, the particles can move past one another, and in gases, the particles are mobile and can move randomly. The particles arrangement in solids are arranged regularly in a lattice. The liquid particles are arranged randomly, and in gases the particles are arranged randomly too. Changes of states. Boiling and evaporation are both endothermic processes. Boiling and evaporation are processes that involve the conversion of liquid into gas. Both these processes allow molecules to move further apart from each other. For example, you're boiling water. While boiling water, the water gets boiled due to the heat you give it through the flames. And even in evaporation, imagine you keep a glass of water on the rooftop. Won't the water evaporate? It evaporates due to the heat present in its environment. Difference between boiling and evaporation. Boiling happens at a set temperature called boiling point. Evaporation occurs at any temperature below the boiling point and above the freezing point. Boiling occurs throughout the liquid, while evaporation occurs only at the surface. Boiling is a relatively faster process, while evaporation is a very slow process. The boiling point of water is 100 degrees Celsius.
The reverse of evaporation is condensation. So condensation is the process by which a gas, a water vapor here, converts into a liquid form. This change is brought about by the change in pressure and temperature of a substance. This phenomena we experience on daily basis. We see the mirror is covered with fog once done taking a hot water bath. There are small beads of water on the mirror. How did this fog develop? Where did these beads of water come from? So the answer is condensation. It's a process through which the water vapor present in the air is converted into liquid water. When the water is present in the gaseous form in the air, it is called as water vapor. Thus, we can say that any process that slows down the particles in the system due to heat flow outwards is therefore exothermic. Condensation has particles of a gas slow down to form intermolecular forces and transition into a liquid phase. Similarly, freezing has particles of a liquid slow down to form lattice structure and become a solid phase. Melting, freezing, and sublimation. Melting is the process in which a solid converts to a liquid. It happens at a set temperature called melting point. Melting point of water is 0 degrees Celsius. Freezing. Freezing is the process in which a liquid converts into solid. It happens at the same temperature as the freezing point. Freezing point of water is 0 degrees Celsius. Sublimation. Sublimation occurs when solid has enough energy to convert into a gas. Sublimation. We can define sublimation as the transition of a substance from the solid phase to the gaseous phase without changing into the liquid phase. This process is an endothermic phase or endothermic reaction. Endothermic reactions are chemical reactions in which the reactants absorb heat energy from the surroundings to form products. These reactions lower the temperature of their surrounding area, thereby creating a cooling effect. Transition that occurs at a temperature and pressure below the triple point of a substance. So what do you mean by a triple point? The triple point is the point at which the pressure and temperature of the substance are such that it can exist in all three states of matter simultaneously. Changes in temperature and pressure causes matter to change from one state to another. This change is called a phase transition or phase change. Examples of phase transition including the melting of ice, that is a solid, into a water, which is a liquid, and the boiling of water into a water vapor, a gas. Here are the names of the phase transitions between solid, liquids, and gases. The first one is melting, which is a phase transition from a solid to liquid. Second, freezing. phase transition from a liquid to solid. Vaporization, it's a phase transition from a liquid to gas. Condensation, a phase transition from a gas to a liquid. Sublimation, phase transition from solid to gas. And deposition, phase transition from a gas to solid. The cooling curve represents the change of phase of matter as it cools. It's a temperature time graph that shows how the temperature of a substance changes as it undergoes a changes of state, typically from a gas to a solid. Cooling curves can be used to determine the temperatures at which changes of state occur. Here, once all the gas has turned into liquid, the temperature starts to fall again, and the liquid begins to contract until the freezing point is reached. At the freezing point, intermolecular bonds between the liquid molecules start to develop to form a solid. At the freezing point, the temperature remains constant until all of the liquid has solidifies, since the energy released due to bond formation cancels out the energy lost due to cooling. Clear representation of bond formation from water to ice. It starts with the cooling of a gas. Particles of a gas move slower and slower, and the gas contracts to form water. The gas is nothing but water vapor. The particles are now closer together. The intermolecular bonds start to form between them. Once the condensation point is reached, the temperature of a substance starts falling. The energy is released by bond formation. This graph represents the cooling curve. Heating curve. On heating, the particles of a solid starts to vibrate faster and faster in their main positions, and the solid begins to expand. Once the melting point is reached, intermolecular bonds between the particles begin to break. The temperature of a substance at this point remains constant until all the solid has turned into liquid, because the energy received by the system is cancelled out by the energy used to break the molecular bonds. Moreover, once all the solid turned into liquid, temperature starts to rise again, and the liquid begins to expand until the boiling point is reached. At this point, the boiling point, the intermolecular bonds between the liquid molecules start to break and form gas. Eventually, at the boiling point, the temperature of a substance remains constant until all the liquid has vaporized and formed gas. Since the energy absorbed by the substance is cancelled by the energy used by the breakdown of intermolecular bonds. The heating curve is a graphical representation of the correlation between heat input and the temperature of a substance. It can be used to determine the melting point and the boiling point of a substance. Here we can see the heating curve, the solid changing into liquid and then changing to gas. In between we have the melting point and the boiling point. Diffusion. Diffusion is the process by which different fluids mix as a result of the random motions of their particles. The main idea involved in diffusion are particles move from a region of higher concentration towards a region of lower concentration. Eventually, the particles are evenly spread. The concentration is the same throughout. However, the rate of diffusion in liquids is much slower than in gases. Diffusion does not take place in solids as the particles cannot move from one place to another. Effect of relative molecular mass in diffusion. The rate at which gases diffuse differs and depends on the gas molecular mass. Not all gases diffuse at the same rate. The speed at which a gas diffuses depends on the mass of particles involved. At the same temperature, molecules that have lower mass move on average faster than those with a higher mass. The ammonia and hydrochloric acid fumes react when they meet, producing a white smoke ring of ammonium chloride. This smoke ring is made of the particles of solid ammonium chloride. The fact that the ring is not formed halfway along the tube shows that ammonia, the lighter molecule of the two, diffuses faster. Important points derived from the kinetic particle theory are: heavier gas particles move more slowly than lighter particles at the same temperature. Larger molecules diffuse more slowly than the smaller ones. The rate of diffusion is inversely related to the mass of the particles. The average speed of the particles increases with an increase in temperature. Effect of pressure and temperature on gas. As we all know that gases are compressible. By changing the pressure acting on them, their volume can be changed. An increase in external pressure produces a contraction. Thus, the gas is said to be compressed. When there is no external pressure acting on the gases, the volume increases. Thus, the gas is said to be decompressed. In this picture, we can clearly see how the volume decreases with increasing pressure. As the gas particles come closer to each other when the pressure is increased. Thus, we can conclude that the volume of gases are affected by temperature. When the temperature is increased, the gas molecules have more kinetic energy and hit the walls of the containers more often and with greater force. This causes increase in internal pressure and increased volume. But when the temperature is decreased, the gas molecules have less kinetic energy and hit the walls of their container less often and with reduced force. This causes decrease in internal pressure and decrease in volume. Now, let's check our knowledge with these MCQs. So let's get started. Which of the following relationships is not correct? Pressure is directly proportional to volume. Volume is inversely proportional to pressure. Volume is directly proportional to temperature, or pressure is directly proportional to temperature. So, the incorrect relationship is pressure is directly proportional to volume. Why? Because given the temperature is constant, if the temperature remains same, pressure is not directly proportional to volume because an increase in pressure compresses particles, thus volume decreases. Which of the following is an example of diffusion? Ice melting to form water, heat transfer from one object to a cold one, a plant absorbing water through its roots, or oxygen molecules moving from an area of higher concentration to an area of lower concentration. The example of diffusion is oxygen molecules moving from an area of high concentration to an area of low concentration. Because the definition of diffusion states that diffusion is the net movement of particles from a region of higher concentration to a region of lower concentration as a result of the random movement of particles until equilibrium is reached. How does increased temperature affect a gas? No effect, decreases volume, increases volume, changes the shape but does not affect volume. The answer is increased volume. As the temperature is increased, the volume increases. What happens to solid particles when heated? Particles vibrate slower, no change in particle vibration. Particles vibrate faster. Particles vibrate in circular path. The answer is particles vibrate faster. So the solid particles, when heated, the particles start vibrating faster. Choose the order that correctly shows the rate of diffusion in ascending order. Ascending means from the lower rate to the higher rate, or the lower level to the higher level. Gases, liquid and solids, or liquid gases and then solids, or solids, liquids and gases, or solids, gases and liquids. So which is the rate of diffusion in ascending order? The right answer is the gases have higher rate of diffusion compared to liquids and solids. Which row correctly shows the properties of liquid with regard to volume, shape, arrangement of particles? The correct answer is C, as liquids have fixed volume. It does not have fixed shape as it takes the shape of a container, and the particles move past one another, and thus they are randomly arranged. What is the particle arrangement in a liquid? Particles are stationary. Particles can move past one another. Particles move in a straight line, or particles move in a circular path. So, as particles in liquids can move past one another. Name the process where the gas is directly changed to a solid without changing into liquid. Sublimation, condensation, melting, or deposition. Which answer is correct? When the gases change directly to solid, this process is called as deposition. In which substance are the particles at a greater distance from each other? Air, water, wood, or light? The correct answer here is air, because air is a gas. The particles are farther away, and water is a liquid, wood is solid, and light is considered as a wave. What happens to gas particles when cooled? Particles move faster when gas expands, or particles start moving and gas freezes, or particles move at the same speed and gas remains the same, or particles move slower and gas contracts. When the particles are cooled, particles move slower and the gas contracts is the correct answer. Which change of state cause particles to come slower? Vaporization, sublimation, condensation, or melting? The correct answer is condensation, because condensation is a phase where the gas is changed to a liquid, thus bringing the particles closer to each other. What is the effect of molecular mass in diffusion? Molecular mass has no effect on diffusion. Lower mass molecules move faster. Higher mass molecules move faster. All molecules move at the same speed. The correct answer is lower mass molecules move faster. Name the process in which solid turns into a liquid. Freezing, evaporation, melting, or sublimation. The correct answer is melting. The process in which the solid turns into liquid is called melting. What is the difference between boiling and evaporation? Boiling is slower and evaporation is faster, or boiling is faster and evaporation is slower. Both are at the same speed, or it depends on liquid. The difference between boiling and evaporation is boiling is faster than evaporation. How does added pressure affect a gas? Does it decrease the volume, or it increases the volume, or it has no effect, or it changes the shape but does not affect the volume? The correct answer is decreases the volume. When the pressure is added on gas, it decreases the volume. Which section of the curve does the substance stay as liquid? A, B, C, D. Correct answer is C. C is a phase where the substance stays as liquid. In this graph, you can see that section C in the question matches part C in the diagram.